Hi, this is Anna Weissmeyer from the Institute for Learning and Brain Sciences at the University of Washington. This is a presentation on the results of our paper published in the Journal of Experimental Child Psychology. In this paper, we find that infants can learn cause and effect relations by observing the consequences of others' interactions with both people and objects. Children of all ages watch the people around them. These observations are a rich source of causal information. Science shows that even children as young as 2 can learn valuable causal lessons from watching what others do. We call this observational causal learning. In 3 experiments, we investigate whether children can use observational causal learning to learn about both physical and social causal relations. In Experiment 1, we tested infants' observational causal learning of a physical causal relation between 2 objects and a marble dispensing machine. The only cues to causality were the observed effects of the experimenter's actions. The experimenter used no causal language, there was no spatial contact between the causes and the effects, and pedagogical cues, such as eye contact and infant-directed speech, were matched for both objects. To the infants, it appeared as if shaking one of the objects caused a marble to dispense, but performing the same shaking action with the other object did not. The key question was whether infants would be more likely to reproduce the experimenter's act on the causally effective object than the causally ineffective one. To measure infants' observational causal learning, each participant received both a touch and a shake score. Scores closer to 1 indicate that infants made contact more often with the effective object for that particular measure, while scores closer to 0 indicate that infants made contact more often with the ineffective object. Chance responding was 0.5. In Experiment 1, infants were more likely to act on the effective object. As shown from this camera angle, the child touches the effective object and then shakes it while looking toward the marble machine in anticipation of making it dispense a marble. The findings support the inference that infants can learn causal relations from observing another person's causal interventions, even in the absence of spatial contact or linguistic descriptions. But what happens if the outcome isn't physical? What if it's a social outcome? If you ask someone to flip a light switch to turn on a light, your request is a cause and the effect is the change in the other person's behavior. We wanted to know if infants could learn how to cause a person's behavior to change by watching that person's interactions with another adult. To investigate this, in Experiment 2, we use the same causal displays from Experiment 1, except, as you can see in the diagram on the right, we replace the marble dispenser with a social outcome, that of an adult dispensing the marble. The experimental question was whether infants would perform the correct intervention to get the person to dispense a marble. And we found that they did. As in Experiment 1, infants were more likely to act on the effective object than the ineffective one. They were able to use their observations of a social interaction between 2 people to make decisions about their own future acts in the same social situation. These results show that infants' observational causal learning is not limited to learning about causal relations involving physical outcomes. One unexplored question is whether observational causal learning of social events can incorporate probabilistic or imperfect evidence. In our everyday lives, our actions don't always turn out how we want them to. This is particularly true of social interactions, which often include an element of uncertainty. For example, when a child asks their mother to bring them an apple, she may sometimes say yes or she may sometimes say no. Can infants succeed on observational causal learning tasks when the objects work some, but not all of the time? We investigated this question in Experiment 3. In Experiment 3, we presented 2 groups of infants with probabilistic causal displays. One group observed physical causal displays, as in Experiment 1, and the other group observed social causal displays, as in Experiment 2. But now, infants would choose between objects with differing levels of effectiveness. One object worked 4 out of the 6 times it was used. It was 67% effective, and the other worked 2 out of the 6 times it was used. It was 33% effective. We found that, despite observing uncertain probabilistic evidence, infants acted significantly more often than chance on the more effective object than the less effective one. These findings support the conclusion that infants' observational causal learning of physical and social causal relations can incorporate probabilistic evidence. These results advance what we know about the development of social and causal learning in several ways. First, they show that infants can learn novel causal interventions from observing the outcomes of others' actions, even in the absence of linguistic support or spatial contact between the cause and its effects. Second, infants can learn causal relations simply by eavesdropping on social interactions between other people, in the absence of dyadic teaching directed toward the infant themselves. And finally, they show that infants learn not only when the causal relations are deterministic, but also when the patterns of evidence are probabilistic in nature. In sum, we think that observational causal learning is a powerful mechanism in early childhood development.